Hello. So today we'll be looking at stoichiometric problems. In studying AP chemistry, is important for us to be able to relate macroscopic properties such as mass to microscopic properties such as number of atoms or molecules. So we'll be looking at how this is done. We're going to start by looking at an example. How many gold atoms can be reduced can be produced by the reduction of 5 grams of tetrachloride by citrate ions. So here we have an equation to illustrate this. For AP chemistry, you'll be encountering new terms like tetrachloride, citrate. You don't need to know these formulas. They'll be given to you. So here we have an equation to show the relationship between tetrachloride and citrate to produce gold. So the question is asking us how many gold atoms can be produced by the reduction of 5 grams of tetrachloride. First thing we need to do is to convert moles. Then we're going to perform the moles to mole stoichiometry. We know that moles is equal to mass in grams over molar mass. That's something we should have been aware of. If not, you need to commit this to memory. Number of moles is equal to mass in grams over molar mass. So we have 5 grams of tetrachloride. This can be converted to moles if we determine the molar mass. The molar mass we can always determine by using our reference table. We're going to look for gold in our reference table, the mass for gold. We're going to look for the mass for chlorine. We realize that there are 4 chlorines, so we're going to add up all these mass. You should get a mass of 338.778 grams per mole. Now, number of moles again is equal to mass in grams over molar mass. So we started out with 5 grams. So it's gonna be 5 grams over 338.778 grams, and you're gonna get approximately 0.0148 moles. So we know that the 5 grams of tetrachloride is equivalent to 0.0148 moles. So looking at the mole ratio for the equation, we can tell it's the same number of moles of gold that will be produced. So let's take a look at this equation. We have 2 moles of the tetrachloride, and we end up with 2 moles of gold. So this is 2 to 2 is the same as 1 to 1. So whatever moles we started out here is going to be the same moles we end up here. So therefore we will have 0.0148 moles of gold. Now we need to convert moles to number of atoms. Now in order to do this, we have to bring up our Avogadro's number. For those of you who have a little problem with Avogadro's number, you may need to refresh your memory. Avogadro's number is equal to 6.02 times 10 to the 23. And what Avogadro's number for stoichiometry is 6.02 times 10 to the 23 molecules is equal to 1 mole of molecules. Or 6.02 times 10 to the 23 atoms is equal to 1 mole of atoms. Okay, so 1 mole of gold atom is equal to 6.02 times 10 to the 23 atoms. Therefore, 0.0148 moles, that's what we worked out before, would be equal to, this is a direct relationship, so we're going to multiply that by Avogadro's number and divide by 1. So we're going to get 8.89 times 10 to the 21 atoms of gold. So that's the amount of gold will be present in this. Hope this helps.